Okay, as we look at this Chapter 10 review, I'm going to go through a few of these. The first section, remember arithmetic is when you're adding or subtracting the same number over and over again. Geometric is if you're multiplying by the same number or dividing neither one. If it's neither one. Like for example, number 1 goes 1, 4, 9, 16, 25. That's a pattern because those are perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. But you're not adding a constant number or multiplying by a constant number, so that would just be a neither. Let's jump down to the arithmetic. Find the indicated term, so looking for the 23rd term, so you're finding a sub 23, you know your first term is 5, plus your d, which is a negative 2, times n minus 1, except we know that n is 23. So your 23 minus 1 is 22, so we have 5 minus 2 times 22, so 5 minus 44. So our 23rd term is negative 39. Let's jump, looking for the 47th term on 5. Jump down to 6. You just want the generic nth term. Looks like we're adding 22. I do want you to simplify this, so I want you to distribute and combine like terms. So we end up with a sub n equals 22n minus 15. By the way, on the next one, you don't know the first term. You're going to have to find the first term first. So notice that you're starting with 22. You don't know your first term. You do know d is 9, so you're adding 9 every time. So 22 was the sixth term, so your n value was 6, so you're plugging in your 6 there. This will allow you, go ahead and solve now to find out what a sub 1 is. Once you know what a sub 1 is, then you can go ahead and do your a sub n term formula like we did on number 6. Number 8, 3 arithmetic meanings. We've got 7, and then we've got 3 blanks, and then I've got a 67. So I know since it's arithmetic, I'm adding d once, twice, 3 times, 4 times. If I started at 7 and I added d 4 times, I ended up at 67. Solving this will give me what d is, and then I can go and actually add it in to find those missing terms. If we jump down to number 9, find the sum. We need to know what n is, first of all, so we would use the sequence formula. So a sub n, well that's negative 29. It's equal to your first term, which is just 3, plus d, which is a negative 2, so minus d, or minus 2, rather, times n minus 1. We don't know n. Let's go ahead and actually subtract that 3 right away. So we have negative 32. Distribute your negative 2 if you like. Add 2, or subtract 2. Divide by negative 2. N is 17. Now I can find the sum of these 17 terms. So 17 times your first term minus, plus your last term, which is a negative, divided by 2. So you're averaging them. It's negative 13 when you average those. So 17 times negative 13 is going to be negative 221 as your sum. Number 10, you can just plug in the calculator. Number 11 is just like number 9. You have to find out which term that is. That's a sub n for now. Your a sub 1 is 6, and looks like your d, you're subtracting 3, so negative 3. And so now it becomes a problem like number 9. Number 12, now we jump to geometric. So I'm looking for the 6th term. Negative 64 is my first term, times my r to the power of n minus 1, so 6 minus 1, so we're doing a 5 there. Negative 64 times 1/2 to the 5th power is a total of negative 2. Number 13 is like that. Now just nth term in general. So your first term, looks like we're multiplying by negative 1/3 to the power of n minus 1, and there's no simplifying to do there, so you're finished. Notice in number 15, you don't know what your first term is. So you have 48, you don't know the first term, times r, which is 2. 48 was the 4th term, so you have an n value of 4, so 4 minus 1. So 2 to the, ends up being 2 to the 3rd, which is 8, so divide both sides by 8. giving you 6 for the first term. And now that you know your first term, now you can go ahead and write your rule for your nth term like they asked you to. You could go ahead and finish it. 2 geometric means, so you've got 6 blank blank and then 16 ninths. So it's geometric, so I know I'm multiplying by r once, twice, thrice. So I started at 6, multiplied by r 3 times, got 16 ninths. I don't want to divide by 6. Simplify that fraction. When you divide it by 6, we end up with 8/27. So instead of dividing by 6, you can multiply by 1/6 if you like, and then simplify. Now when we cube root that, because I want to get rid of the 3, you cube root both the numerator and the denominator, giving you 2/3. So your r value is 2/3. Now you go ahead and multiply it. So take 6 times your 2/3, you get 4. Take 4 times 2/3, you get 8/3. Those would be the 2 geometric means. Find the sum of the geometric series. So the sum of these 6 terms, your first term minus your first term times r to the nth power. I gave you another variation of that formula. You're welcome to use that if you know it. Otherwise, just plug this in the calculator. You can get either a fraction or a decimal, depends on, I guess, how you write your answer. As a fraction, it'd be 7,812 over 5, or as a decimal, that's 1,562.4. Number 18, you can plug in the calculator. Number 19, you can plug in the calculator. Number 20 through 22, make sure you check to see if it exists first. Check your r value, see what you're multiplying by. Looks like in this first one, I'm multiplying by -1/2. 21, the r value, the power, the number that got raised to the exponent is 1/2. While number 22, the number that got raised to the exponent is 3/2. Notice 3/2 is larger than 1, so number 22 is going to have no sum. Don't bother doing anything with that problem. The other two will have a sum, so use your formula. The formula says your first term, divide r over 1 minus your r. So in our denominator, we end up with 1 plus 1/2, which is 3/2. So -12 divided by 3/2 will give you your answer. Meanwhile, on number 21, your first term, you have to find out what your first term is. So it says to start with 1. Plug 1 in for your n. So 1 minus 1 becomes 0. My exponent is 0. 1/2 to the 0 is 1. So 2 times 1 is 2. Your first term was 2. You had to find that first. Then your denominator is 1 minus your r value, and so you could go ahead and finish that problem. 23, the first 5 terms, well, they give you the first term. So then if you're looking for the second term, it says to take the term before, the first term, which was the 4, and subtract 13 from it, giving you -9. So then to find the next term, take the -9, and you're just subtracting 13, so -22. Take then, sorry, I don't know, I didn't mean to write 13 there. -22, the answer we just got, subtract 13 from that. -35, and then for your last one, take the answer you just got, the -35, and subtract 13 from that, giving us -48. So 4, and then those are our first 5 terms. 24 is like it. 25, be careful because it does also introduce the in there, not just a sub in. So let's go ahead and take a look at this one. Your first term is 4. Find your second term. Take 3 times the term before it, which was the 4, and then from it you're going to subtract in. Remember, the subscript we're using here, 2, is really n plus 1, so it's 1 more than n. So if I subtract 1 from 2, I get 1. That's my n value. So 12 minus 1 is 11. So then when I'm looking at the third term, 3 times my last term. This time, 1 less than 3 is 2, so I'm subtracting 2, giving me 31. And then so on and so forth. So plug in your 31, subtract your 3 this time, get your answer, plug it in again to find your fifth term. 26, write the recursive rule, so you have to indicate what your first term is, and then tell what you're doing after that. Looks like I'm subtracting 6, so that would be your rule. And then this last one, when I jump to this one, your first term is 1, and then After that, you're taking your term, you're squaring it, and you're adding 1.